how does a computer find the fastest route? A delivery driver visits dozens of places every day. Which route would we choose? The shortest route is not always the fastest. A road under construction or a route with many traffic lights can take more time. Sometimes taking the highway is much faster, even if it means going a little farther. Computers face the same problem. When we send photos or watch videos on the internet, the data does not travel to its destination all at once. It moves through many computers and routers. These devices are called nodes, and the paths that connect them are called links. Just as roads connect cities, the internet also forms a vast network by connecting countless nodes. So, how does a computer choose its path? For example, imagine there are two routes from A to B. The first route is a narrow side street. It is shorter, but it has many traffic lights and heavy traffic. The second route is a little longer, but it is a wide highway. Most people would choose the second route. Computers work the same way. Passing through fewer nodes is not always the fastest route. Each link also stores information, such as how long it takes to travel and how much data it can carry. These values are called weights. Weight does not only represent distance, it can also represent time, cost, or data transfer speed. For example, when traveling abroad on a business trip, flying is the fastest option. However, when exporting thousands of cars overseas, ships are used most of the time. They can carry much more cargo at once, even though they take much longer. In other words, the best path depends on what matters most. So, how does a computer find the best path among countless paths? One of the most well-known methods is Dijkstra's algorithm. This algorithm works much like a navigation system. When a destination is entered, the navigation system checks the surrounding roads one by one and calculates the fastest route. If it finds a faster route along the way, it immediately recalculates the route. Dijkstra's algorithm works the same way. It first selects the node closest to the starting point. If going through that node is faster, it keeps updating the information. By repeating this process, it finds the most efficient route. Now, consider a slightly different situation. Suppose we are building a new apartment complex. What if we connect all 100 apartment buildings with direct roads? Cars could travel anywhere directly, but building all those roads would cost a huge amount. So the construction company tries to connect every building while building as few roads as possible. Computer networks work the same way. If every computer connects directly to every other computer, the installation cost becomes too high. So we keep only the necessary connections and make sure every computer can still communicate with one another. This method is called a minimum spanning tree. The two main methods for building a minimum spanning tree are Kruskal's algorithm and Prim's algorithm. Kruskal's algorithm connects the cheapest roads one by one. In contrast, Prim's algorithm keeps extending the network by connecting the nearest new village to the villages that are already connected. There is one thing that must always be avoided: a cycle. For example, if we build a road that goes in one loop around the same village and returns to the starting point, it only costs more money and does not create any necessary new connections. So a minimum spanning tree does not create this kind of loop. Remember just one thing. Dijkstra's algorithm finds the shortest path on roads that already exist. In contrast, a minimum spanning tree builds the roads themselves at the lowest possible cost. If navigation systems in cars are similar to Dijkstra's algorithm, then designing the roads of a new city is similar to a minimum spanning tree. Today, graph theory is used not only for the internet, but also for navigation systems, railway and power grid design, logistics and delivery, and even analyzing relationships between people on social media. The internet that we use every day is a vast network created by countless nodes and links. And at this very moment, mathematics continues to calculate the fastest routes and the most efficient ways to connect them.